Hi, this is the part fourth of modeling spatial relationships videos, and in this part we'll discuss ordinary least squares, that is the linear regression. And this is something about me. I'm Dr. Zubairul Islam. I'm working in the Department of Geography at Igrat University. So here the arc map is open and we are ready to perform our exercise, that is the ordinary least square exercise. We have the data, and let me first introduce my data to you. Here, this data is the Ethio regions, and the data which I have, that is the at zonal level, and you can see the data. I'm opening the attribute file here. At zone level, you will find the built-up area, the population, and the GDP, and yeah, this is some kind of the socioeconomic data. So be sure that you have ID at means the ID with integer property. Here I have created this ID here one. So what this tool do for you is actually this tool is mm, this tool perform global ordinary least squares. In short, it is known as OLS, linear regression, to generate the predictions or to model a dependent variable in terms of its relationship to a set of explanatory variables. So this is very important. Why? Because if suppose if you have some missing values, then you can predict the missing values based on some explanatory variables, and that is good for further analysis also, and the existing analysis is also very important. Its importance lies in the fact, as we know, that regression analysis is probably the most commonly used statistics in the social science. Regression is used to evaluate the relationship between two or more features, attributes. It identify and measure the relationship, and this relationship let you better understand that what's going on in a place. It predicts where something is likely to occur, and or it begin to examine the cause of why things occur and where they do. So it's important, very important for geographical investigation. uh, OLS is the best known for of all regression techniques. It is not means OLS is best known of all regression techniques. It is also proper starting point for all spatial regression analysis. So there are another analysis is also another regression analysis, but this is the most common one. So it provides a global model of variable or process you are trying to understand or predict. It creates a single regression equation to represent that process. So let's begin it. I'm opening this ordinary least squares here. You have to give the input feature. You have to give the unique ID. You have to give the location here. I'm leaving it as default. I want to know about the GDP 2015 as an independent variable, and let's take the explanatory variable as population, and built up area 2015. We can take night light also. Okay, I think it is two variables are enough. We'll see. the result with the help of two explanatory variables. And we can give the output report file, the location, and this is OLS result. Here we can give OLS result here, and there are some additional options also which we can, if we want, then we can export as a coefficient output table and diagnostic output table, but here in this case I'm just leaving it, and let's see. Okay, so here we have got the result, and the result is showing that means it is showing the standard residuals, and the yellow part is somewhat not there is no much variation. But here if we see the result, right click, open attribute table, and we can see the estimated residual and observed. You see here GDP, this is the observed here. Which place is this? This is Addis Ababa. So this is observed one, and estimated is this. Estimated is this, and residual is here, and standard residual is 0.32. So it is perfect in relation with the, I mean, it is not much, there is no much deviation in relation if we compare relation with the population and the built up area. But some of the places where deviation is more, the standard, I mean the deviation in negative, where the estimated is more than expected. Here it is important to understand. As we can see, this minus 1.7 is towards negative side, means it is less, it is less, very less than estimated, than predicted. So these are the zones where GDP is less compared to the population and built up area. Which are the zones where it is like this? So we can zoom in and we can see that these are the zones where the GDP is much lesser than expected from the, it means from the viewpoint of the relation from the population and built up area. But some of the villages where GDP is higher than expected, estimated, or predicted. Which are these areas? This is 2.5, and this is the zone here. You see, let's level it. Let's see, level this. Yeah, here this zone, at this zone, I think Borena, and there are some another zones like North Gondar, Asosa also, where GDP is more than expected or predicted. And this prediction, keep in the mind that this prediction is in relation with population and built up area. So for more, we can see the PDF file which we have generated. So this is the file, this is the summary of OLS results. These are the coefficients. The intercept is here, and the coefficient of built up is this. we can call it B1 or something. This is B2. So the relation with population is better than built up because this coefficient is less here. So all this is the result built up. Some of the place you can see here the built up is this very high in some of the zones. So here kurtosis is very high, and you can see the skewedness is positive. It will be positive. And if you will see the population is not as much, is kurtosis is not as much high as from built-up area, and the values are very close to the this regression line. So this is the standardized residuals here. So you can study this report, and this report will give you much idea of the data of the dependent and independent variables. So this was about the OLS, ordinary least square technique, and in the next video we will talk about the geographically weighted regression and how it is different from OLS. So thanks for listening and thanks for watching.